Okay guys, in this video, we're going to be taking a look at how to convert from a decimal to a binary and a binary to a decimal. Now this is a whole lot easier than you think. Now, I'm going to show you a nice, quick, easy way of doing this. I know there's some ways that some people told me and some other ways that I've seen other people do it, and then I watch them do it and I get confused myself. So do it my way. It's pretty easy, and you're going to be surprised to see how relatively easy this is going to be, or at least super easy in my opinion. So let's get started into how to convert from a decimal to binary, binary to a decimal. All right, we're going to be using my trusty OneNote. Here I am with OneNote. So in order to do this, we're going to have to make a little chart. Now it's not a complex chart. It starts with the number 1 and it doubles itself. So we're going to start with the number 1, 2, 4, 8, 16, 32, 64, and 128. All right, so that's easy, right? You just keep doubling the number. Now, why did I stop at 128? Well, because I only wanted 8 digits, because an IP address is 4 8-bit numbers. I'm really just stopping at 8 because I want 8 bits out of it. And I'll explain more of that later in the next video and so on. So look at this. 1, 2, 3, 4, 5, 6, 7, 8. So we got 8 numbers there. With this chart, remember, you start at 1, just keep doubling it. That's all. With this chart, you're now going to be able to convert any decimal up to a certain amount. We'll take a look at the end of this video, to a binary and vice versa. Let's see how to do it. Let's say the number 26. What is the binary equivalent of the number 26? Well, if you're using my little chart at the top, it's relatively quick and easy. Watch. You just got to say to yourself, what numbers there on that chart adds up to 26? Put a 1 where they are. Put a 0 everywhere else. That's all there is. Watch this. So 16 and 8, right? 16 plus 8 is 24. Plus 4 is 28. We don't want that. Plus 2. Put a 0 here. So you put a 0 where you don't want those numbers, and you put a 1 where you want those numbers. What adds up to the number you want? You put a 1. Wherever you don't need it, you put a 0. So 26 in binary is 1, 1, 0, 1, 0. Yep, that's it. That's all there is to it. Let's try another number. 49. 49. What would be 49? So 49 would be 32 plus 16 would be 48. You don't need an 8. You don't need a 4. You don't need a 2. You need a 1. 49. So it'll be 1, 1, 0, 0, 0, 1. There you go. 49. Let's try another number. Let's try the number 99. 99. So 99 would be what? Okay, now I'm literally just making this up as I'm doing it. So I'm hoping my math is right. You got to get your math right. So 64 plus 32. So this would be 64. You need that. 32, you need this. 96. Okay, so we need 3 more. So you don't need this. You don't need this. You don't need this. You need 2 and you need a 1. So 99 would be 1, 1, 0, 0, 3 zeros, right? 0, 1, 1. Let's try a much bigger number. We'll say 177. 177. So we'll say 128. Do you need 64? No, that'll be way too big. That'll actually be 192. Nope. 160. Yep. 16. Right? We need that. Be 176. 0, 0, 0, and a 1. There you go. Hopefully that's right. It is right. It's just I don't know if my math is right. So 128 plus 32 is 160. 60 plus 60 would be 176 plus 1, 177. Yep. 1, 0, 1, 1, 0, 0, 0, 1. Then you might be saying, Andrew, is there a way to check that? Yes, there is. And we're going to check it in a minute. Let's do one more and then we're going to check all of these. Let's say 240. 247. 247 would be 128 plus 64 would be 192 plus 32 would be 224. 240. There's a reason I know that. We're going to see why come up a little bit later. 0, 244, 246, 247. So this here would be 1, 1, 1, 1, 0, 1, 1, 1. Good. Now, you could use this chart to go backwards. Okay, you could use this chart to go backwards. If somebody gives you a binary and they say, convert this binary to a decimal, you could do it, just take the numbers and plug them in. So let's say they give you a number like 1, 0, 0, 1, 0, 0, 0, 1. Just made that up. Let's see what this one gives you. So I'm just going to plug it in right into the top. So we're going to say 1, 0, 0, 1, 0, 0, 0, 1. So this is equivalent to 128 plus 16. 128 plus 16. Oh, you know what? We're going to use a calculator for this because, and I want to open the calculator too because I do want to show you something about this. So 128 plus 16 plus 1, 145. So as you can see, converting the binary to decimal is not that difficult. Now I did open the calculator for a reason, because this Windows calculator actually has the ability to test our binary skills. So to do this, we're going to change this to a programmer, and then you just put in the number and the binary shows up like right there. This is a Windows 10 box, by the way. Let's try it out. So if you put 26, now you notice this one has zeros on the left. Now I told you zeros on the left means nothing. So it's going to be 11010, 11010. So we are correct on that. 49 would be 110, 3 zeros on a 1. So we're correct on that. Let's just jump to 2. Let's just jump to 177 here. 1011 and 3 zeros on a 1. So we're good on that one. 247, it's 4 1s, 0 and 3 1s. That's correct. And then the 145. So 1, 2 zeros and a 1. Yep, 3 zeros on a 1. Okay, so you can see the Windows calculator is actually just doing this for you. So I want to talk about, that's as hard as this gets. Now, did you get it? It wasn't that difficult. Now, was it? All right, it's pretty easy. You just make the chart. Now, I want to just mention something. I shouldn't, but I'm just going to mention it. That the way that chart is actually based on exponents. It's 2 to the 0. This here is actually like 2 to the 0. This is how other people teach it. They'd be like 2 to the 0, then 2 to the 1, then 2 to the 2. It gets too complex. I hate that method. That's why I don't teach it that way. I just write out the number. I think it's pretty easy just to put the numbers across and then just put the numbers to add up. Okay, I do want to mention something though. What if you put all zeros? You know, my father used to tell me something. From nothing comes nothing. So all 0, the number 0 in decimal is equal to just 0 in binary. You don't need to put all 8 zeros. But what happens if you put all 1s? What if you have 8 1s here? Then what? Well, let's add it up. 128 plus 64 is 192 plus 32 is 224 plus 16, 240, 248 plus 4, 252, 254, 255. So the number 255 is a number between, is basically 8 1s, right? 3, 4. Okay, good. So these are bits. These are written in bits. So we have 8 bits. Remember, a bit is either a 1 or a 0. So if you take 8 binary bits, the minimum value they can give you is 0. But the maximum value they can give you is 255, right? So you can never get bigger than this because 8 bits, you see, if you add a 1, you make that 128, 256, and the next set, then you have 9 bits. You don't want that. An IP address, an IP version 4 address is basically 4 8-bit numbers, right? So it basically 8 bits is going to be a number, is going to be this number between 0 and 255. See how easy that was, right? So binary equivalence. Now I want you, just don't stop the video and move on to the next one. I want you to practice this by yourself. Here's what I want you to do. Make up some numbers, plug it into the chart. Practice this a little bit. Just make up any numbers. Remember, the number has to be between 0 and 255. You can't get a bigger number than this. And if you're wondering, does that work with every decimal between 0 and 255? Yes, it does. Every decimal between the numbers 0 and 255, that table will give you the binary equivalent of it. So do a few, try it out, test it with the Windows calculator, and then move into the next video where we're going to be talking about, where we get into talking about IP addressing. All right, so do some practice, and I'll see you in the next video.